Yes, dear friends, I want to explain two experiments which are used to find focal length of convex lens as well as concave lens in class 12. One method is UV method, तो simple है कि you put object here between f and 2f or beyond 2f, you will get here. Suppose I put like this. Now you will get here the image like this. This ray pass through focus and optical center. So you will get here inverted image. Now how to locate the position? How to locate the position? This object here between f and 2f. You will get magnified inverted image. Put the other pin here below this. Close your eye, one eye, and keep the eye on the image pin and object pin. Now rotate your neck left to right, keeping one eye closed. If there is occur no change the position of this, means they remain together. They remain together like this. Then parallax is removed. Parallax, I told you what is parallax. If an observer see two objects in the same direction while he in motion, then there appear relative motion between the two. The farther object move with you means in the motion of in the direction motion of the observer, while closer one goes backward. This relative motion between two objects observed by moving observer is called parallax. If there is no, if the two are the same distance, there occur no displacement. So that way you can find out the position by noting this is U and this is V. You can find out focal length. On optical bench there are numbers centimeter. Suppose it is at 20 centimeter, it is at 50 centimeter, it is at 80 centimeter. So 50 minus 20, 30. तो object distance हो गया. Image distance भी suppose it is मैंने बताया 20 or 50, 30. It is suppose at 90. तो 40 centimeter भी हो जाएगा. And remember, while using equation, proper sign use कीजिएगा. So this is one method, but this is not in your syllabus. In your syllabus is that find the focal length of convex lens by plotting graph between U and B. U and B के बीच में graph बना सकते हैं. So for that actually the graph obtained will be like this. Since U negative, such type of graphs will occur. Now to obtain a curve, we should have a large number of readings. 3 or 4 readings will not help here. You need to take a big number of readings. How to take that? Generally in labs, the optical bench is of nearly 150 centimeter. In my lab, I had this optical bench of 150 centimeter. So what to do? It is optical bench. Suppose it is 0 mark. It is 150 mark centimeter. Put the lens at 75 centimeter. This is at 75 centimeter. Put the lens ठीक है भाई. At 70 centimeter. Then put object at 0 mark. Object pin. So it will be far away beyond 2f. You will get a very small image beyond f. Here. Put the pin and get the parallax removed. note the position of lens तो 50 है ही, suppose it is at 85 like that, or anyone depending on focal length. Now you have taken this reading. Now displace it by 5 centimeter. Bring it. Keep the lens fixed. The image is little this side and get the palette removed. Then 5 centimeter. It will be little bigger. A little bigger image will be there than this. And now place 10 centimeter away from this position. Image will go this way. Become little more than. And then 10 centimeter by, and keep on putting till your image comes here. A bigger image is obtained here. Have you got my point? यहाँ पर बड़ा image दिखाई दे हमें. So that way you can plot, you can obtain 7 or 8 readings, and then plot graph. Actually, generally focal length of 20 centimeter होता है, 20 centimeter होता है. तो यहाँ पर जो ये U और V होगा, यहाँ ऐसा किंक मार करके आपका पहला जो ऑब्जेक्ट डिस्टेंस होगा तो बहुत बड़ा होगा यहाँ, तो उससे कोरोस्पोंडिंग V छोटा होगा ना भाई. फिर ये इधर छोटा क्या है, ये यहाँ पर पॉइंट मार्क हो जाएगा ऐसे, यहाँ पॉइंट मार्क होगा, फिर यहाँ तो थोड़ा पॉइंट, क्योंकि V में थोड़ा ही चेंज आएगा. And so on. Keep on putting. It may happen that all these points may be at different places. So don't move like that. Plot the graph so that all points are close to the graph. भाई आपका जो ग्राफ बनेगा यूवी का, हो सकता है पॉइंट कुछ इस तरह से आ जाए, एक यहाँ, एक यहाँ, एक यहाँ, कोई यहाँ, कोई यहाँ, कोई यहाँ. तो आप जो है ऐसा बनाइए जो कॉमन ये पॉइंट इसके आर पास हो. Now draw perpendicular bisector here. So these two distance will be equal. दोनों इक्वल होंगे. इमेज डिस्टेंस ऑब्जेक्ट डिस्टेंस इक्वल कब होते हैं? When in this situation, image distance, object distance are there in convex lens. When object placed at 2f, image will be at 2f. So this value of V will be 2f. This value will be 2f. To measure this scale we have taken, so suppose it comes 40 centimeter. So f will be 20 centimeter. This is an important experiment done in labs. Now I have seen. So my point is there, if you have to take here at least 7 or 8 readings, not 2 or 3. You please read the book also, and you must have good practical book. Now there is one more actually problem. Many times question has come on this graph in competitive exam as well as board exam. अभी हमने कहा था कि वो कॉनकेव लेंस के लिए 1/V, तो कोई भी लेंस हो ये ग्राफ आएगा. वो कहते हैं प्लॉट द ग्राफ बिटवीन 1/V एंड 1/U है भाई. तो कैसा ग्राफ बनेगा? 4 कॉन्वेक्स और कॉनकेव लेंस. तो graph between 1/U and 1/V. Actually, compared with y is equal to mx plus c. इसको इधर ले जाएंगे तो ऐसे जो ना 1/V equal to 1/U plus 1/f. y c. So when 1 upon u is 0, when 1 upon u is 0, so 1 upon v is equal to f. Suppose 1 by f this much. ये 1 upon f, and then graph will be straight line. This graph will be a, and this value will be 1 by f. क्योंकि फोकल लेंथ 20 सेंटीमीटर बाई 20.05 लाइक दैट. यहाँ पर जब नंबर होंगे डिजिट जो होगी 0.02, 0.03, 0.04, 0.05 एंड सो ऑन. तो दिस टाइप ऑफ ग्राफ कैन आल्सो बी आस्क्ड. Now how to find focal length of concave lens? Because in concave lens, you know, image is virtual and you cannot locate the position of virtual image. So how to find the focal length of concave lens? Focal length, class 12 and competitive exam question is asked on this also. Focal length of concave lens. How to find this? I told you while telling plane mirror, for real object in plane mirror image is virtual, but for virtual object image real. The same thing is here. Concave lens produce virtual image of every real object, but if object for concave lens is virtual, it may produce real image. Now see how to find this. Actually, we put convex lens and concave lens coaxially on same principal axis. Anyway, now put the object here. Object will, I write only point. So this is convex lens. So ray start from here. If this lens had not been there, then the ray had gone like this. And we have got image. This image formed by convex lens will act as virtual object. But this concave lens means diverging lens. Diverge this here like this. And you will get image somewhere here. Then how to obtain this picture there? First you put both the lenses. You will see first this image, not this one. Note the position of this image, object position, convex lens L1, L2 on optical bench. You will remove the parallax here by putting the pin. Note this position now. Replace this concave lens. Replace this concave lens. Object is there. Don't change the position of object. Then you will get this image here. Now you can remove the parallax. Then note this position. I told you for concave lens, image formed by convex lens act virtual object. So, and it's a real image. So for concave lens, मान लो it is C1, C2, C2I dash U, and it is B. So in lab, please, if you want to perform, put the two lens first. Actually, in some books, process has been described. कि first obtain this image, then put the lens here and get parallel. वो होता नहीं. We are unable to do that. First put both the lenses together. There is a problem here in concave lens, because concave lens form diminished virtual erect image. For this concave lens, this convex lens is the object. तो इसका छोटा इमेज दिखागा इसमें, और this image also will be seen smaller one. So be very careful and note the image, see the image formed by combination of lens here. Remove the parallax, put the pin like this, rotate your eye, if they are together then no parallax. And once you go parallax remove this lens. Don't display, keep this fixed as such. Then you will get image here. उसके लिए फिर पिन लगाएंगे, तो ये पोजीशन यहाँ से यहाँ तक का होगा U और ये होगा इसके लिए V. तो you can find out focal length of concave lens also. Now one more situation which is very interesting and important. If I place here convex lens on optical bench and a plane mirror here parallel to perpendicular axis, I put an object here and I may get image here of same size. How it is possible? If I put the convex lens and this plane mirror and get the image of same size on the object itself, so it is only possible if ray starting from here, after it fall normally, normal ray reflected back on the same path. So if ray falling normally means they become parallel, because mirror is perpendicular axis. If ray have become parallel, then diverging beam from become parallel. So it is the focus. This point is focus and this is a focal length. So ray will be reflected back and come back here. Now it does not matter where it is placed. You can place it in contact also like this. The same thing. Image will be again obtained. So this is the focal length of focus point of convex lens, and this distance focal length. You know, in case of concave mirror, if object placed at two again C, you get real image of same size at C. So this combination of plane mirror and convex lens will behave like a concave mirror whose radius of curvature is this. अगर ये इमेज बनना है ऐसे, तो ये जो इमेज अगर बन गया है, ये डिस्टेंस जो है, this convex lens and plane mirror behave like concave mirror whose radius of curvature is this. R होगा उसका ये, यानी कि सेंटर ऑफ कर्वेचर होगा of concave mirror which is equivalent to this combination of plane mirror and convex lens. Keep in mind, there comes a question कि plane mirror है, उसको यहाँ silver कर दिया, plano concave, we get image at suppose here at 14 centimeter. How it is possible? तो इस तरीके से लोग कहते हैं it behave like a concave mirror of focal length 10 centimeter, means 20 centimeter will be the center of curvature, radial curvature. तो वो ऐसे आएगा. है भाई। तो ये इसका अगर ही इमेज बनना है तो इट बिहेव लाइक कॉनकेव मिरर और फोकल लेंथ 10 centimeter. Then if object placed at 20 centimeter, so real image will be obtained. If we remove this parallel and not similar, so we have called parallel. Parallel होगी तो इसका मतलब 20 centimeter होगी focal length of concave lens, plano concave lens, like that. फिर वो कहते हैं this side is silver, it behave like concave mirror of focal length 7 centimeter. तो फिर क्या होगा कि उसका radius of curvature 14. If we put object on 14 centimeter, we will get image here, and that is not possible. It will fall normal here. They reflected back. It means it is a radius curvature of curved surface. Radius curvature of curved surface ही हो जाएगा. And we can be calculate, वो पूछते हैं कि what is the redundance of this lens. क्वेश्चन है इस तरह से, तो ऐसे क्वेश्चन भी जिक्र होगा. प्लीज बी केयरफुल. थैंक यू.